Alright, this is Tim Ultebruns. I'm going to talk about my Project 1 for AI. So, starts off with the XML node class, which is has a pointer to its parent node. It's got a string for a name, a vector of attributes. I probably end up changing that to a hash map of some sort, and a vector of its children nodes. And the attributes are just a key and a value string. The key can't be empty or null. And so the magic happens in the XML builder class. And most of everything comes through the stream operator here. And we do have a looper function called build that streams a stream until it cannot stream no more into the input operator here. And so this is the choreography code, which has a while loop and a switch statement, so you can give the stream function any amount of XML at a time, and it will work off of a cursor root class or implementation of a XML node. And so it can tolerate whatever white space, and it'll actually build the stream in real time as you give it data. And we've got all the implementation functions at the bottom. You should be able to get the gist from the stream operator. And then in our XML utils class, we have our searching and our stochastic selection. So we've got a template here for a depth first search that uses a functional, which is right here. Yeah, it uses a functional that takes a constant XML node pointer as its input and outputs Boolean whether this is the node we're looking for or not. And so basically this template function does the traversal until it finds a match, and if it doesn't find a match, it returns null pointer. Same deal goes for breadth first search, and then we have two implementations here, as well as being able to specify your own functional to do any implementation you'd like. And so swatch it over to the depth first search here. And so this is the attribute search, which isn't used anymore, which you specify an attribute and it will return a node that contains that attribute, matching by key and value. Or we can simply search value. Switch back over to the documentation here. String to misspelled compare. Okay. Will allow you to it searches the node name and attribute value. So we have a little find if when, first of all, if a node's name matches, it goes ahead and returns true. But if not, it searches its attributes through the vector iterator, and it has another functional which matches the attribute value to the given value. And then at the bottom we've got our stochastic response, which, swap back over to the documentation, I probably misspelled that, or it's just not in my dictionary. But it's going to select a leaf node, which was later modified to mean any node that has a response on it. So it'll select within your response. So if a node with a response has child nodes with responses, it will allow you to pick that parent node. Otherwise, it just selects from the children and recurses until you've got a node without any children, which then will cause problems later if you don't have any response attributes on that leaf node, which I'll catch later. And over here we've got unit tests. Don't need to worry about those. There's a lot of those. Then implementations in main right here. A short little function to mock up sample given functionality. So it will read in a file called behaviortree.xml from whatever your working directory is, and it will print it out. I didn't go over the printing deal, but it's mundane. And then it loops for input until you do quit, and then it searches for said behavior node using the search breadth first, and then it selects a response using stochastic response, and then it will select the response attribute from said XML node, and if it doesn't happen to exist, we'll go ahead and continue and tell you that the leaf node you hit doesn't have a response. Otherwise, it's just going to output the attribute response value and continue. So I'll go ahead and run through it real quick. Alright, so here's our tree. Should be familiar with it. Idle, use computer, use computer, root. Alright, so that's my XML parser.